Good afternoon to all of you. Myself, Professor N.V. Adpe from SNT College of Engineering and Research Center, Yevla. The today's topic is solution of polynomial and transcendental equation by using Newton Raphson method. In that, the topic which is covered, that is derivation, how to derive the formula which is required for problem solving by using Newton Raphson method. Again, a numerical on the basis of Newton Raphson method, advantages and disadvantages of that method. The Newton Raphson method, which is required or which is used to find the solution or to find the root of polynomial or and transcendental equation by using Newton Raphson method. In that method, there is only one guess. There is only one guess is required instead of another method, that is bisection method, and in a regular policy method there are two initial guesses are required. But in that method, only one initial guess is required. And suppose there is a one graph is given. Suppose this is your graph and one initial point, that is xi is the initial guess, and the function of the function f of x at that initial guess is f of xi is will be shown in that graph. According to that graphical representation of Newton Raphson method, we can draw a tangent. We can draw a tangent from a point xi comma f of xi. One tangent line should be drawn from the point xi comma f of xi, and this tangent line will be intersect to the x-axis. This is called as a new guess. This is called as new guess. That is xi plus 1. That is xi plus 1. Means the value of new guess or a root is estimated by drawing a tangent. By drawing a tangent at point y1. That is xi comma y, xi comma yi. Means the coordinate axis. The coordinate is xi comma yi, and the point is yi, whose coordinate are xi comma yi. The tangent intersect x-axis. The tangent will be intersect to the x-axis at a new point xi plus 1. This is your new guess. From the initial guess, we can find out the new guess by using this formula. Xi plus 1 is equal to xi minus f of xi divided by f dash of xi. How this formula will be derived? By using this derivation, tan phi, this is the angle phi. This angle is phi. According to the right angle triangle, tan phi is equal to AB divided by AC. AB divided by AC. What is the AB? AB is nothing but your f of xi. This is y coordinate. F of xi minus 0. And AC is xi minus xi plus 1. Xi minus xi plus 1. And how but we will find out the xi plus 1 by rearranging this formula. Xi plus 1, this will be taking left side, and f of xi divided by f dash of xi is equal to xi minus xi plus 1. For finding the xi plus 1, xi minus f of xi divided by f dash of xi. This formula will be derived by this is your Pythagoras theorem also, or by using slope line also. The algorithm first, how it can be find out by solving the numerical, the steps which is required to solve the numerical. That is, first step is to find the f dash of x. F dash of x means the derivative of function f of x. Take a derivative of f of x. Again, find out by using this formula. Find out the next guesses. Next guess, xi plus 1 is equal to xi minus f of xi divided by f dash of xi. Again, find out the relative approximate error, which should be less than the tolerance, which should be greater, or in that step we can check the relative error which is greater than or less than the tolerance which is required. Again, compare the absolute relative error with the tolerance. Suppose it is the error which is greater than the tolerance, then go to the next step. And if the error which is less than the tolerance, then stop stop for the calculation. Check if the number of iteration has exceeded the maximum number of iteration allowed. If so, one needs to terminate the algorithm and notify the user. Suppose we given the in a numerical, find the solution of the any polynomial equation by using Newton Raphson method up to 4th iteration. Then we can only find out up to the 4th iteration. This is one example to find the root of equation. What is the root of equation? This is the value of x. The value of x satisfies the function f of x is equal to 0. Satisfies the function f of x is equal to 0. This is one example. The equation that gives the depth x in a meter means this is a one ball. This will be depth in the water up to the depth is x meter, to which the ball is submerged under water is given by f of x is equal to x cube minus 0.165 x square plus 3.993 into 10 raised to minus 4. Use the Newton's method to find the roots of equation to find the depth of x. Depth of x means the root of equation to which the ball is submerged under water. Conduct 3 iterations to estimate the root of the above equation. Means in that method only we perform the 3 iterations up to the 3 iterations. Again, find out the absolute relative approximate error at the end of each iteration. But after solving each iteration, we can also find out the error. The number of significant digits at least correct at the end of each iteration. Means after the end of any iteration, suppose iteration number 1, iteration number 2, the significant digit, at least one significant digit should be correct. This is your problem statement. Again, the solution. For solution, we can write the function, that is f of x is equal to x cube minus 0.165 x square plus 3.993 into 10 raised to minus 4. For finding the initial guess, suppose assume solve for f dash of x. We can find out the derivative. F of x is equal to x cube minus 0.165 x square minus 3.993 to 10 raised to minus 4. For finding the derivative, x cube derivative is 3x square minus x square derivative is 2 into x, means 2 into 1, 0.165 is 0.33 x. Let us assume the initial case of root f of x is equal to 0 is x0 is equal to 0.00, sorry, 0.05. 0.05. This is a reasonable guess. Discuss why x is equal to 0 and x is equal to 0.11 meter are not good choices. As the extreme values of the depth, x would be 0 and the diameter is 0.11. The diameter of that ball is 0.11. So find out the first iteration. X0, x1 is equal to x0 minus f of x0 upon f dash of x0. Put the values of x0 in that equation. x0 is 0.05 minus f of x0. Put the values of x0, 0.05 cube minus 0.165 into 0.05 square plus 3.993 into 10 raised to minus 4. Divided by 3 into 0.05 square minus 0.33 into 0.05. After the calculation of this total calculation, the x1 is 0.6242. 0.6242. Again, find out the error. Relative error. Relative error is x1 minus x0 divided by x1 into 100. 0.06242 minus 0.05 divided by 0.06242 into 100. This is 19.90%. The number of significant digits at least correct is 0. This 0 is present in that number as well as in that number. Both the numbers are same. Means the solution of after the solving the iteration 1, the solution is correct up to the one significant digit. Correct up to the one significant digit. Again iteration number 2. Then find out the x2. x1 minus f of x1 divided by f dash of x1. Then put the values of x1, 0.06242 minus 0.06242 bracket cube minus 0.165 into 0.06242 bracket square plus 3.993 into 10 raised to minus 4 divided by 3 into 0.06242 bracket square minus 0.33 into 0.06242. After solving this all the calculation, the value is 0.06238. 6238. For after the iteration number 2, we can also find out the relative error. Relative error. Relative error. Relative error. The absolute relative error is x2 minus x1 divided by x2 into 100. That is 0.06238 minus 0.06242 divided by 0.06238 into 100. This is your 0.0716%. Means this is very small error is present. Means after the completion of iteration number 2, the root of equation is accurate up to the 3 decimal places, 062, 062. the significant digit at least correct in the answer is 2. Again iteration number 3. We can find out the x3 by using the value of x2 minus f of x2 divided by f dash of x2. Put the values of x2 in that equation and solve. After solving the all the calculation, after performing all the calculation, the value is 0.06238. Means the value is same as the value after the iteration number 2. Means after the iteration number 3, the relative approximate error is 0%. The relative approximate error is 0%, and the answer is correct up to the 5 decimal places. Correct up to the 5 decimal places. This is your method to solve the or to find the roots of polynomial equation by using Newton Raphson method. By taking a simple formula, x1 is equal to x0 minus f of x0 divided by f dash of x0. The advantages of this method is converges fast. If it converges, requires only one guess. It requires only one guess. Instead of bisection and regular falsity method, they require the two initial guesses. The drawback of that method is divergence at inflection points. Means the selection of initial guess is or an iteration value of the root that is close to the inflection point of the function f of x may start diverting away from the root in the Newton Raphson method. Suppose the solution is close to the initial guess, or initial guess is close to the exact value, and if we use the divergence method, then the answer will be diverted from the exact root. For example, f of x is equal to x minus x1 bracket cube plus 0.512 is equal to 0. The Newton Raphson method reduces to xi plus 1 is equal to xi minus x1 cube minus 1 bracket cube plus 0.512 divided by 3 into xi minus 1 bracket square. Means the table 1 shows the iterated value of the root of the equation. And the root starts to diverge at iteration 6 because the previous estimate of 0.92589 is close to the inflection point of x is equal to 1. Means suppose we use the divergence method for selecting the initial guess, the answer will be wrong. This will be only one drawback of that Newton Raphson method. This is your Newton Raphson method. The overview of the Newton Raphson method is it requires only one guess to find out the solution or to find out the root of equation, root of polynomial and transcendental equation by only one guess, and only one simple formula is used for finding the next guess is x1 is equal to x0 minus f of x0 divided by f dash of x0, and again find out the next iteration. There is no bracketing method. For finding the new guesses. This is your Newton Raphson method. This is a simple method to find the root of polynomial equation. only it has only one case. Only in the drawback is, suppose initial guess is not given, then to find the initial guess, the method is very long. The method is very long or very complicated. This is your Newton Raphson method. Okay. So thank you. Thank you very much.